Good evening, everyone, and welcome to today's webinar by the Institute of Product Leadership. The Institute of Product Leadership is a B school dedicated to product leaders and innovators. We have 4 campuses located across the globe with over 1,600 delighted alumni from over 200 companies. The School of Data Science at the Institute of Product Leadership offers an MBA in Data Science and Business Analytics. This is a 24-month-long intensive program that is intended for professionals with 0 to 7 years of work experience. The program is run in collaboration with the MIT University in Pune and will also be launching shortly in Bangalore. We also have month-long skill boot camps across a variety of areas. Some examples of the boot camps we have are data science for decision making, programming for data science, machine learning, advanced data modeling for decision making, big data engineering, and data visualization and consulting. Coming to the webinar for this evening, we are delighted to have with us Jayavaradhan Sambedu, who is our speaker for today. Jay is the head of emerging trends and technologies at Societe Generale, and the webinar theme for this evening is blockchain. A couple of minutes are not sufficient to speak about Jay, but I'm going to try my best anyway. Jay is a seasoned IT professional who is currently leading emerging trends and technologies at Societe Generale. In the past, while at Infosys, he has worked for several leading global financial institutions such as Deutsche Bank, Royal Bank of Scotland, Citizens Bank, and the Union Bank of Switzerland. Jay is also the founding vice president of the India Blockchain Forum, which advises the government of Andhra Pradesh and the government of India on various blockchain initiatives. Jay has recently addressed key stakeholders at the International Petroleum Week in London in 2017. He's also regularly seen speaking at leading tech summits and meetups, such as the NASSCOM Product Enclave, for example. Jay has addressed blockchain topics across various countries, such as Switzerland, the UK, France, India, and Singapore, apart from regularly communicating with various business leaders, both within and outside the Societe Generale group. The key takeaways that you can expect from this evening's webinar with Jay are the following: to understand and appreciate why blockchain matters, to comprehend how it fits into the financial policy of various countries and banks, to know about the type of jobs that the rise of blockchain will create, and also to understand the skills required for you to work with blockchain systems. A couple of announcements. You can join our LinkedIn group, IPL School of Data Science, to stay in touch and get regular updates on the latest trends in data science and also access short, impactful videos by various data scientists and uh, subscribe to our event updates, etc. For questions that you would like to pose to Jay uh, over the course of this webinar, you can type them out in the question and answers window. You can also tweet to us at School of DS. I repeat, at School of DS, and you can chat with us on our Facebook page, the IPL School of Data Science. The best question for that is posed this evening wins this book, Blockchain Revolution by Don Tapscott and Alex Tapscott, a book that has been highly recommended by Jay himself. So without further ado, I'm going to hand over to Jay for what I'm sure is going to be a completely enthralling webinar this evening.
Good evening to all the attendees for the webinar. As I was invited by IPL to present a session on blockchain, which is one of the emerging technologies that has ended up capturing the imagination of many. So through this session, I would want to educate you on what this trend is all about. What are the sort of various jobs that exist in the scope of the blockchain as an industry? And where are we seeing more and more use cases that are being applied using blockchain? So those are the segments I would want to cover as a part of today's session. So one of the first things we would want to, before we go into understanding blockchain, as a distributed ledger, as we call it, it's better to understand the origin of this entire technology. Why was there a need for such a technology to come into existence in the first place? Now, many of you may have heard of different type of cryptocurrencies. If you see, traditionally, currencies in any country are a reflection of the country's the policies, right? The strength of a currency is often seen as a strength of is a reflection on their economy, and it's also seen as a reflection of the buying power of the currency. So there's a whole lot of things that goes into what makes a currency, and many countries, as you know, are on the fiat sort of currencies. But one thing that is common amongst all these are centralized. These are run as instruments of policy by a government that has been elected. So typically, this is how currencies have always been. Now, in 2009, right at the time when a lot of banks were getting bailed out, there was a quirky little white paper that came out. And this white paper spoke about how a world where currency could be completely decentralized. This was not obviously taken seriously by many, but in any other time, if such a paper had come out in the world, people would have ignored it. But at that point, the sentiment of governments bailing out banks for some of the bad loans that were taken was so high that people started to take a look at what this currency was all about. Now, this currency, which today we know quite popularly as the Bitcoin, and the white paper, what I'm referring to, was the one written by Satoshi Nakamoto way back in 2009. Now, what made this so special? Bitcoin was the world's first decentralized, digital, virtual cryptocurrency, right? Now, all these keywords are quite important, and this distinguishes this currency from any other type of currency what you may have come across. The first thing is it's decentralized in the sense, technically, there is no central authority that is controlling creation of this asset or distribution of this asset. It is not centralized, which is the case, for example, if you take India, RBI is responsible for creation of this currency, and banks who act as agents work as intermediaries to distribute them, but not so in the case of of Bitcoin. Bitcoin is decentralized in the sense technically any of these miners can end up creating. I'll tell you what the miner is, the background image. I'll give you the context before we go there. The second important aspect of this was it was virtual currency. In the virtual currencies are not new. I mean, you may have been comfortable using Paytm or PayPal. So what this means is you have fiat money in some account. You're able to transfer this to another account, and you're able to use it seamlessly. So virtual is not special, but Bitcoin has this feature. Next most important part is it's a digital currency. Now this is where it gets tricky. Digital currencies have been existing in the world of gaming from a long time, where you could use assets that you procure within an environment or an ecosystem and use it for purchasing something within the same ecosystem has existed. But taking this currency and using it for a whole lot of real world payments, that's where this digital currency bit became quite important. And finally, as I said, it's a cryptocurrency. There's a lot of cryptographic elements that go into protecting what has made the elements of this currency. So if you see the fundamental tenets of what a Bitcoin was bringing in, it was different from most of the fiat currencies that have, most of the fiat currencies that exist in the systems today. To elaborate the point a little more, if you had, for example, let's say an asset like a watch, and you had only one version of this watch that was ever available on this planet, it is pretty straightforward. If you hand over this watch to another individual, it is very clear there was only one copy of this watch that existed. And once you hand it over to someone else, obviously there can't be a duplicate of this watch. I'm not talking about counterfeit or anything. If there was only one asset, it is very clear if an asset is physical. But Let's assume a world where the watch is not a physical asset, but a completely digital asset. So it's more like having an image of a watch and not really a watch itself. Now it opens up a huge set of problems. Imagine a world where I just had an image of a watch. How do I guarantee that once I transfer this image of a watch to another person, I cannot create copies of the same watch and give it to X, Y, and Z? If you take this concept of what I explained from a watch to the value of to money, you can see how the problem becomes a lot more complex. If I only had, let's say, a 2000 rupee note and I hand it over to a individual with that unique reference number, I know there should have technically been only one note with that number, right? But what happens if I only have an image of the 2000 rupee note? In this case, there was no way for people to figure out if once I've given this copy of this 2000 rupee note that I haven't created multiple copies. Now, if you see in an essence, that is the problem Bitcoin had to solve if it had to make the four tenets of a decentralized virtual digital cryptocurrency come alive. And this is exactly what that white paper did. It showed a way of using a platform through which you could ensure all these four parameters that I just mentioned. The platform that helped to protect Bitcoin from ensuring that it could not be counterfeited, or ensuring that once it is used, someone else won't be able to reuse it. That platform is what is today known as blockchain. So I'll go back a little more detail on what makes a blockchain, but here is a quick, capture of what really happens when a Bitcoin transaction takes place between two entities. Now, for Bitcoin transactions, unlike real world real world real fiat currency transactions, what you require is a Bitcoin wallet. Now, these wallets are can be downloaded from any of the standard app stores. What you have, once you have this wallet that is configured, what ends up happening is all these wallets are connected to something called nodes. I'll explain all this in detail as we go ahead. This is just to explain how a Bitcoin transaction works. These nodes are geographically distributed. They're all over the planet. And the only way you're recognized on the system is through a public and private key combination. Now, the private key is not supposed to be revealed, of course, but the public key is how you are recognized on the network. So if anyone wanted to send you a Bitcoin or any cryptocurrency of this nature, the only way for them to do is if they know what your public key is. The moment they know what your public key is, you don't have to go through any centralized authority to go through any checks. It's not like adding, a beneficiary in your bank account and going through NEFT kind of centralized systems. Here, the moment I have a public key of an individual, I can just tag it to them and instantly make a payment to them if I wanted. So the moment I do this, what happens is my public key and using a combination of my private key, a digital hash is created, and this is distributed to all the nodes that exist in the network. Now, although there are multiple nodes that are connected in the system, there are some specialized nodes that exist, and these are called miners. The job of the miners is to verify whatever has happened till now follows the rules of the system. In the sense, it is not a duplicate transaction. There is a hash that is getting generated. I'll explain again all the hash and all that a little bit later. And it ensures that once a transaction is used, it can never be reused for any other transaction. It ensures all of this, and only after this is done, it goes through a sort of a lottery system to figure out. It's not really technically a lottery. It's called a proof of work. There's a consensus protocol that is triggered, and at the end of it, the miner who managed to get this list of blocks certified is granted a set of cryptocurrencies, which today is about 12.5 bitcoins, if we are talking about bitcoins, for a miner who manages to successfully discover a block. And this is how bitcoins can ever be generated. But once you have a Bitcoin, as in a miner gets a Bitcoin, you can buy Bitcoin off the market today, you have some websites in India as well, where you could go provide your INR and in return be credited with a Bitcoin, which you can use for a series of transactions. So this is what you need to get as a context of what is a Bitcoin, how does a Bitcoin transaction happen, and how does a blockchain go about enabling this. And this is the context for this image. So how does the blockchain part really work? So we saw the elements of Bitcoin and what it does. But to really make this sort of cryptocurrency work, there are some underlying elements what a blockchain requires. The first and foremost element that it requires is extensive use of something called cryptography. Now, this may have been a term that a few of y'all may have heard in the past, but for those of y'all who haven't heard, cryptography is using. This is something that has been directly from the world of military. If there are two ways in which information can be sent from one party to another, and again, think of it from a military analogy, right? If I wanted to send information about how my armed forces are going to attack, or I need to send information about what the enemy is doing on the other side of the spectrum, there was one way where you take the entire information, as it is, and you hide the information and send it across to the other side of to wherever you're interested to send. Now, the problem with sending information like this is, if at all people figure out how you've hidden this information, once the information is unhidden in a way, the whole information is given away to people who shouldn't have got the info, and then it puts the whole operation at risk. That is one way of doing it. This is called steganography. The other way of doing it is you take whatever is the raw information that you want to transfer to another person, you apply some sort of algorithm on top of this, you convert this information into some sort of gibberish that people cannot understand directly, and send it off to the other side. Now, even if someone intercepts your information, there is no way for them to figure out what this information really stood for. Now, one of the biggest employments of this sort of a technique was done by Julius Caesar. He used something called Caesar shift in his, and the way that worked is the alphabet starts from A to Z. What he used to do was using a special keyword, which could be like Caesar or Hail or some four digit or five alphabet keyword. When you put that and you offset the alphabets, for example, A will now become a H and B will become a I, and so on. And now you take whatever is your main text and you apply this sort of alphabet, not the original alphabet. Suddenly you change the very nature of what is the text there, what you've sent. Now, if even someone accidentally comes across the text that you have, if they're not able to identify what was the initial algorithm that was used to convert this, there is no way they'll be able to figure out what was the information that was being exchanged. Now, this is what Caesar shift is, and I'm talking about this quite some time ago. From there to, if you see now, with the advanced features we've got in computing, cryptography has come a long way. And one of the key elements that we use in a blockchain-based system are something called SHA. This stands for Secure Hash Algorithms. This is used extensively for protecting any communication that happens on the blockchain-based systems, any digital signature that is applied on the system, all of them use the SHA system. Now, I'll just give you an example of how the SHA works. Here you see this is a sentence, and for this entire sentence that you see on your left-hand side, when you run it through a SHA 256 hash, you get a weird alpha, you get an alphanumeric as you see on the right side. Now, any small change in the input data can result in huge changes in the output data, but irrelevant to where you are on the planet, as long as you are applying the same hashing function on the same text, the result will always be the same. So as you can see, the second example, brown, the word was introduced, it was changed from one place to another. As you can see, the text has changed massively from how the first hash was. You see the third sentence, we just added a full stop, and you see the hash has no relevance to what the original statement was. And as you can see, irrelevant to the size of the text, for example, you could have 1 terabyte of data on the left hand side. The output will always be a unique 256, character value, which uniquely represents whatever you're putting on the left hand side. Now, this is an amazing property of in cryptography. As you can see, this sort of information can be used to figure out digital signatures that are signed and sent to someone. These are technical concepts called commitments. All these rely on a huge amount of math that happens behind the scenes, and SHA is unidirectional. You cannot use the right hand side of the function and ever understand what the original text was. But with the original text, if you apply the hashing function, you will always get only this value. So you can clearly see this can be a huge asset to how you can exploit in the crypto world. So this is used extensively in the blockchain-based system. The second most important part of what you have is something called a digital signature. Now, many of you may have used RSA tokens if you are in any banking system, or if you're connecting using Citrix servers to your from home to your corporate networks. You would have seen RSA token. Now, these tokens are something where you would have seen the numbers change quite frequently. Now, if you see what is happening behind the scenes, what it's exploiting a very interesting feature in mathematics, which is about prime numbers. You see, prime numbers are not uniformly distributed. When you look at from number theory, when you study it in detail, it's very difficult to predict which is the next prime number. Now, what RSA uses is a very intelligent way, where if you take two prime numbers and multiply, computers can do this very quickly. You give a multiplication problem, a computer can do it very, very quickly. But when you give the result of this problem, and then you ask the computer to predict which were the two prime numbers that resulted in creation of this final number, now the computer is in a little bit of a fix. It now has to identify the set of prime numbers and then multiply the two prime numbers and then eventually tell you that these were the two prime numbers that gave you the number. I'm obviously grossly oversimplifying, sorry, the problem of RSA. But what you need to understand is it uses this property in mathematics, where prime number multiplication is easy, but once you give the result asking it which were the two prime numbers that made it is slightly difficult. Now, that is what RSA has done, and it has managed really well for all these years. But with today's day and age, what we're seeing is, with the sort of computing power that exists, RSA on very lightweight systems like your mobile phones and so on can be breached. So what blockchain-based systems use is something called ECDSA, which is called elliptic curve digital signature algorithm. Why is this important? Elliptic curves do not use such prime number factoring, where there is at least one way. If you had a super really efficient computer, some good algorithms, there was a chance for you to figure out what were the two prime numbers that made it. But in elliptic curves, it uses a very a part of mathematics that not many people are equipped with, which is on elliptic curves, and it uses properties there which are difficult to breach. Now, just to give you an example, there was a paper written by a security researcher called Arjun Lenstra, and his paper mentioned that if you compare key strength to key strength between RSA and ECDSA, if you took just a 22-bit RSA and applied something called a brute force attack to find out if just for 22 bits, if you had to use brute force to hack it, of course the computers will get hot, technically. And using that heat, what could you do? So they found out, for breaking through RSA, what will happen is it would produce as much heat as heating a teaspoon of water. That's what will happen if you use brute force on RSA. For the same key strength, if you try to use brute force on ECDSA, the amount of energy that it could potentially create can boil all water on planet Earth. So I'm talking about just a 22-bit key, and what ECDSA is used in Bitcoins are 256 bytes Okay, so it's like a big difference between the two. So this is the difference. All digital signatures on the blockchain-based platform use ECTSA and not RSA-based systems. The third most important part is consensus. What do I mean by this? The data in blockchain-based systems are decentralized in the sense they are distributed across the globe. Now, the moment you distribute the data across, there should be some way for you to figure out how to bring a consensus between agreeing parties. So Bitcoin-based systems use something called proof of work, but there are many other sort of systems that exist today. You have proof of authority, proof of stake. There are different consensus protocols that exist in today's world. And last but not the least, smart contracts. Now, smart contracts are not a new concept. This concept has been in as a concept has been existing from the 90s. But what it means is once you put a code on a blockchain-based system, because you cannot create or you, I mean, it is tamper resistant. You can put a code that cannot be changed, which means you can take a contract. The terms of the contract can be put into a code, and this can be put on the blockchain, ensuring no one will be able to modify it once this code goes into the system. And you can use the code for a lot of things. You know, you could for example, based on some stock positions, you can buy or sell. There's a whole lot of things you can do with the smart contract world. Now, the key thing to remember is cryptography, digital signatures, consensus, smart contracts. None of them are just inventions of blockchain or Bitcoin-based systems. These all have existed in the past. Yeah, it's not anything new. But what Satoshi did in a genius move is he took these technologies which were built for totally different use cases and brought them under one umbrella, and that's what makes the entire blockchain-based system so fascinating. And this is where a lot of use cases are being explored in today's world. So that's the essence of what we're trying to do. But does this mean, with this basic understanding of what I've given you about blockchain, does this mean, I mean, how do you go about making a career in this sort of field?
I think we're having a slight audio issue with Jay's audio, so if you can just give us a minute, we're just trying to get him back.
Hi everyone, please hang in there. Jay will be back with us soon. We have some very interesting questions and answers coming up. Please stay in.
Hi, did you lose me in between?
Yeah, we did for
Hello?
a little while. Hi Jay, can you hear us?
Um, till what point was I on the line, and when did you
We
lose
could
me?
hear you until you started this slide.
Okay. I'm here. Did you hear about the different frameworks that I spoke about, or do I cover that again?
I think you could cover that because it was breaking off in between.
Okay. Is it better now?
Yes, yes.
Okay. Okay. So let me come back on this slide. So on the challenges ahead, I was just starting to explain if you wanted to make a career as a blockchain developer, one of the first things I would recommend is there is a lot of content available already online. There are Coursera courses which you could definitely use to understand a little more about the basics of what makes the blockchain tick. But the best way to learn this is to download the open source code on your own computers and start learning them, building your own virtual machines. There is no other replacement to this if you want to become a seasoned developer. Now, even if you want to go on that route, you will see multiple options to which way you want to go. The easiest one to learn is something called the Hyperledger Fabric. And the reason why Fabric is more easier is because IBM has a big push on Fabric related content. And they've created something called Composer, which makes it very easy for you to kind of create this complex workflow logic on blockchain based system. So you have one option, which is Hyperledger Fabric. The second option you have is Hyperledger Sawtooth. Now, this is again an open source, but majorly pushed by Intel. So that is one option where you could try. There is also Iroha, which is not very popular by developers, but there is an open source framework in that space too. Now, Quorum is JP Morgan's product, which has been open sourced, and this provides very high privacy. It has very similar features like Hyperledger Fabric. This is also something that I would recommend you could download if you're looking at building use cases which require high privacy. Then you have Ethereum itself, which you can run on your test network. You have multi-chain, which is a fork of Bitcoin, which can again be run on your own systems. So all these frameworks are free to use. All you need is time and energy to go through and start learning and building on them. And the use cases can easily build on top of this. It's not a big challenge to once you start getting the hang of it, it is not technically very difficult. But one thing is, most of these the programming languages that are used are not something that is normally known by developers. For example, Corda, R3 Corda uses something called Kotlin, which has very similar properties to uh, Java. But then the reason why such languages are chosen is because the ability to hack it is also limited if people really do not know how if they do not know the language itself in a lot of details. So those are some of the key tips I would say. If you're keen about understanding blockchain and learning, the best solution is and one other recommendation is there's a platform called edX, and edX is a platform for learning more about Hyperledger Fabric. I would definitely recommend any of you who is keen to learn more about this tech to look at edX content too, apart from the other forums where you can learn about them. So those are some of the challenges if you're trying to get into blockchain based space. You need to know the basics really well. Otherwise, even though you can build use cases on top of it, you will never be able to appreciate where blockchain should be applied. And that is the mistake I've seen many developers make. They just try to get in directly, start writing their own smart contracts without realizing what is the underlying tech that is protecting the whole framework. So that's one tip that I have. And the second thing you should remember is a blockchain-based system is introduction of a total parallel network. It is not just a solution like a machine learning solution where you can just load it up in a model and plug it into your IT. That's not how it works. It uses internet to communicate between nodes. So if you end up putting this in use cases where this sort of network that you're going to introduce doesn't add value, it's a whole wasted opportunity if you end up doing it. So these are some of the things that keen developers and who are listeners of this, if you're interested, these are some things that you need to take note of. The next important point is the frameworks. I just explained about them. There are various frameworks that depend on what you want to do. If you want a private blockchain, which is what most banks are now, not just banks, most entities are ending up creating consortiums of their own. So they are running more and more private blockchains. If you run it like that, Ethereum is a good choice if you are running it on the test network. Quorum is also a good choice if you have high privacy. Hyperledger Fabric can be run on both the modes, and it depends on what you want. R3 Corda primarily is driven as a private blockchain, what you run within the consortium. So that depending on the use case, you can choose the framework that you require. We can go on for a long time only on that, but on the interest of time, I'm going to move to the next one. So one big problem with blockchain is today, the standards for blockchain do not exist because it is still being, it's a nascent technology, it's an emerging one, so it is not yet there. I'm already a part of the Bureau of Indian Standards, and I'm a part of the specific wing that is focusing on blockchain standards. And I'm also a part of the international standards. And we clearly see this would take some more time. 2019 and 2020 is when you will see the standards becoming mainstream. But that does not mean you do not have to start working on it. You can continue to start working on these projects, but standards are evolving. This is an aspect that you need to remember when you're walking in this space. The second common grouse you may hear about blockchain-based system is that they don't play with volumes really well. It is true for the Bitcoin network and maybe the Ethereum network initially that it was not able to scale a lot. But once it's only a change in configuration that Bitcoin or all these networks require. And once you change that scale, the volumes that blockchain can handle is a lot more than what MasterCard and Visa can process. It's a lot more higher than that. But to do that, there are side effects that need to be done. But in private blockchains, this is not a problem. This is more on the public blockchain that we see the volumes of transactions is an issue. Now, the second, another big problem when you start using blockchain is you also need to upgrade your internal IT systems to be able to absorb what a blockchain-based system is trying to do. What a blockchain system does, it removes anything that becomes an intermediary. So if your IT systems are not upgraded, for example, if you've built them as monolith applications and they're not more service oriented, and blockchain engages a lot with the API-based connections to your system, it expects you to take a look at your entire IT strategy and figure out whether the cost of using a blockchain-based solution is worth it, or whether there should be some other way you want to do it. And blockchain is not necessarily a solution in all the cases, but in a case where the use case is really good, it's worth trying a blockchain-based one. And of course, if you have a huge amount of legacy, putting in a blockchain that could also end up becoming a frustration because the upgrade of all the other systems need to be done before you start plugging in blockchain one. So these are some of the things you need to remember while you're exploring blockchain a little more in depth. These parameters can go a long way in you choosing the right use case. I'm going to expedite it a little bit. I think we are running a little bit close of time. So just in a nutshell, the sort of challenges that exist in the blockchain world today, one is it's a nascent technology, but it's evolving very rapidly. There are standards, there are multiple protocols, and at least at this moment, there are three major protocols. And we need to see if there's going to be some consolidation that will happen in the coming years. In the existing infrastructure, there are some weak links that do exist. For example, if your system is not ready, we just cannot go plug in a blockchain. And the volume of transactions, people generally use this as a reason for not exploring blockchain. That is not necessarily true. But yes, if you take one of the standard way, software that is existing, yes, volume is a problem if your use case has high volume of data. And invariably, you have to work with existing legacy applications, and that is one big challenge if you're introducing blockchain. Now, how do we take it forward? As I mentioned, the best way to learn something is to experiment it. If you're from any of the companies or a startup, you should start experimenting more on the use cases within a closed environment. And once you're comfortable with it, then use it for beta testing with live customers with a live use case, and then roll it out in small segments that is the way you should use blockchain, not with a big bang approach. There are a lot of startups working in the area of blockchain, and they exist from helping in decentralized IoT to market prediction to ownership of digital content to ride sharing. There's a whole lot of use cases. Again, this slide itself, we can talk for a good one day. I think we will have to progress on some of the other topics we need to touch upon. So, what are some of the global implementations that have happened using blockchain? Well, land records in Estonia and Sweden, they are getting digitized using blockchain so that people do not tamper with the data that exists. In trade finance, a Societe Generale, I led this experiment called Easy Trading Connect. You can just search about this on the internet or on YouTube. You would find a lot of content about this. We tried to see how letter of credit process can be digitized. So we did this experiment with ING, ABN AMRO. Maersk is doing an experiment on their own with IBM, and ICICI worked with Infosys to come up with a solution. So there are stock exchanges which are implementing blockchain, information tech, like Storj is a company that is competing with cloud companies. That is one. So centralized currencies are now becoming more digital currencies, which are government backed. That's happening. Identity management is more like a KYC of yourself, and there's a company called Showcard that's working. And Everledger is a company that is helping to show provenance of diamonds. So a whole lot of use cases are exploring blockchain-based blockchain as one of the solutions what they require. So in India level as well, I'm involved in quite a few use cases, and I can advise because I work with the central government in some of the areas to advise them. One that is being considered is secure storage of digital records. So there's a good use case for blockchain there. Cybersecurity, basically for protecting critical infrastructure, blockchain can be a good source there. All the municipal records so that it cannot be tampered and easily verifiable. That's a good use case. So the market actors. So again here, instead of centralized power, if you can distribute it, it can come back. And finally, transparency. So these are all some of the India use cases, and I can tell you some of these use cases are already underway, and by 2019 you'll see more of them coming up and in this space. So there are some augmenting technologies as well that work in conjunction. Well, Internet of Things, which generates the data. For securing that, blockchain could be of good use. Machine learning and deep learning on top of this. Quantum computing is something that's coming up in the future. It's worth checking, keeping an eye on that. And IPFS is something that is also thought about how the World Wide Web itself will look like. So these are some of the things that are coming as augmenting technologies for blockchain. So that's precisely where we stand about blockchain, and I've tried to keep this information to at least give you a primer on what this is and how you can go about using this, the sort of careers that you can make out of this. Now I'll take a moment to see if there were any questions that you all have come up with, and I can use this opportunity to answer those questions.
We have several questions that have come in for you, Jay, but in the interest of time, we'll stick to just three. So the first question for today is blockchain only for developers wanting to make a career out of it? What about technical managers?
Definitely, blockchain is not only for developers. Technical managers, in fact, the role I play in my organization is more of a technical manager, although I do have good development experience, but my role predominantly is about technical managers. So the same skill sets, what you require here are is the ability to understand the proper use case and ensure that the team who you are managing are able to implement a use case in the best possible manner. So in fact, I would recommend technical managers should definitely have a good understanding of blockchain as an emerging technology, because more and more use cases in the future will have a layer of blockchain below all the other data layer of storage, because it's the version of truth that a blockchain maintains. So definitely technical managers can have a real good career by understanding blockchain in detail.
Okay, the second question for today, how can cryptocurrency be the pathway to a cashless economy and be helpful in lowering in commodity pricing?
So cryptocurrency is not necessarily a solution. I would call it is not necessarily the only solution to a cashless economy. There are already drives that are happening, as you may have seen, to go more and more cashless. Just to give you a point, this is not just a drive in India. In India, we are going more and more towards wallets. You may have seen a host of wallets that have come into the marketplace, and today you are able to transact a lot without really having to use cash. Now you go to the next level. You look at what China is trying to do, and the amount of cashless. The amount of cashless things that are there in China is mind-boggling. WeChat, which is their de facto platform, is used as a in instead of cash in almost any outlet. You in some cases cash is optional, but WeChat is mandatory. That is the sort it's going. But cryptocurrency, at least in the way I look at it, now even governments are trying to push for crypto-based digital currencies that are coming in, but it is not really the solution. Of it is not designed to lower the commodity pricing, or neither to become the only way to reach cashless. So it is not a direct link between the two.
Okay, our third and final question for this evening. Currency is the legal tender of the state. Does the individual only provide the legal tender in the case of Bitcoin? Also, what are the legal wrangles that can come in the way of Bitcoin?
Okay, so the currency is the legal tender of the state, and this is because it is enacted as a law that RBI is the only authority. I'm talking about the example of India. Reserve Bank of India has been created as an act by the Parliament, and they are the only ones who are allowed to kind of print the notes. So yes, it is also a legal tender because the government says so. If you see how this currency is backed, it's a fiat currency. You trust the currency as much as you have trust in the government. And this is exactly why most countries have them as the legal tender. Now, when you buy a Bitcoin, you need to understand Bitcoin is not in any way traditionally as currency is used at all. It's almost akin to using gold. Gold is not technically a currency, but you use it as an asset through which you can purchase services or any other things you want. Bitcoin in many ways has very similar properties to gold. One is there is only a finite amount of Bitcoins that are existing in the system. That is true. For example, at the end of 21st millionth Bitcoin, no longer will the Bitcoin blockchain ever produce any more of this. So there is a finite supply of this is there, exactly like gold. There's no infinite supply. Second one, its value is roughly constant. For example, the value of gold doesn't, the market may decide the price to go up and down, but the way gold is extracted does not have a direct impact on its price. So which is similar to how mining Bitcoins and then the pricing of Bitcoins are totally different, uh, totally different things. So what we need to explain here is when you're using a Bitcoin, all you're trying to do is use this mechanism with someone else who accepts this as currency. That's about it. I wouldn't go into the term whether it's legal tender or not. It's technically not a legal tender. It is just an alternative for you to exchange goods and services. That's what Bitcoin does. The third part of your question is what are the legal wrangles that can come in the Bitcoin? Exactly what I explained in the second point. Since it is a way for you to exchange goods and services, and this is not centrally controlled by a government, it can obviously run in parallel with how the government wants to execute its rights. The whole reason a currency is created is so that all the services and that people avail from a country and how the country collects its taxes, there could be one common means of exchange between the citizens and the country. But if you go into the Bitcoin, by very nature, it is decentralized and it's distributed all over, then it becomes a little bit of a problem. So I would say, as a policy within India, cryptocurrencies do not seem to have the flavor. It is seen as, I would say, there is no active encouragement, and generally it is discouraged, I would say. Although I wouldn't uh, claim it to be illegal. There are a lot of rumors that are floating in the markets. More than illegal, it is frowned upon, but it could easily be categorized as illegal because there are also rumors that a lot of cryptos are getting used in illicit trade. Again, this is lot more speculative than what it is. Yes, there are cases where people use this, but that is not the only reason. There are many people who are holding cryptocurrencies as a legitimate alternative ways of investment. So I wouldn't read too much into it. The legal wrangles are, if more and more people start using bitcoins, then it could slowly start eroding faith in the currency that is the de facto currency. So yes, there could be legal wrangles if these sort of challenges do come into play. So those are the three questions, what I see here. Yeah. Were there any other questions?
No, Jay, primarily these. We did have a couple of others, but I think we're kind of running out of time. So if we could just wrap up,
Okay.
or would you
So
like to
I
take a
hope
couple more
this,
questions? I can.
if there are a couple more questions, I can take, I think. If
Sure.
it would be
Okay.
informative
So,
for them. We
Yes,
lost
we
the
have
audio in
couple more
between a bit,
minutes.
so yeah.
Jay, can
I
you see
think
the questions?
I can see only the three questions. I can't see the other questions. Are there anything else?
Yeah. Can bitcoins be considered as regular tangible asset classes? For example, gold. What factors determine Bitcoin market value, price, and variance?
Okay, I think I answered this question even before it was asked. I didn't see this question prior to this. As I answered previously, for example, when someone's mining gold, right, to the price of gold, there is no direct correlation. As you can see, the mining continues on a day in, day out basis, but the price of gold is fixed by the market on a day in, day out basis. So that's what generally happens. So there is no direct correlation between the two. The price of a Bitcoin is purely based on the factors of supply and demand than anything else, like any other commodity in the market. So there's nothing unique about this.
Okay,
So it is
Jay,
similar to
we'll
gold.
do one last question and then finish.
Okay.
How do the traditional OLTP concepts, like a transaction adhering to ACID properties, fit into the blockchain context?
Okay, so as a standard, relational databases are a very different, or transaction processing databases were designed for very different purposes. These were designed to ensure huge volumes of data were stored and stacked to be analyzed, so to derive some insights. Or if you look at RDBMS in general, it was designed as a relational databases where you had tables which were linked to each other and kind of went one layer above how files were managed. Now, if you look at blockchain, it is not running against any of these principles, but technically the purpose why this is built is not to just remain a database. The strong features of a blockchain-based system are more in line with crypto and basically the cryptography and more of distributed consensus mechanism than to serve as a database. So if your use case requires more of analytics or more of just how relational sort of data to form some insights, you do not need to get into blockchain at all. These can be done through traditional RDBMS. The use cases for blockchain are slightly different and more where you're trying to bring in multiple actors together who do not completely trust each other, and they can use a blockchain based system. So it's not about confusing asset properties with this. The way or the reason why these tools exist are for very different purposes. I think with that, I think we've just at the nick of time, we've come to the last question. So Devika, back to you.
Thank you so much, Jay. So, the winner for this evening is Abhijit for his question on how crypto might assist in a cashless economy. And I think we'll wrap up now. Jay, on behalf of everyone at the Institute of Product Leadership and the School of Data Science, thank you so much for taking time out of your schedule and doing this webinar with us. It's been, I mean, fascinating and a complete learning experience for all of us. So, thank you so much, Jay.
Thank you. Thanks to all the attendees and to Institute of Product Leadership for inviting me.
Thank you so much. Good night, everyone.
Good night.
Good night.